Alright, so this question says an isosceles right triangle is inscribed in a circle of radius 8 inches. Find the area inside the circle but outside the triangle in square inches. Alright, so basically what this is saying is let's draw a picture like we always do. We have a circle right here, and we have an isosceles right triangle inside of the circle. Now, an isosceles right triangle is a right triangle where the two legs are congruent, right? That's the definition of an isosceles triangle. It has two legs that are congruent, and then another side. So that's just any isosceles triangle. An isosceles right triangle is going to have two congruent legs and then a hypotenuse opposite a right angle. Alright, so the thing about any right triangle inscribed in a circle is that the hypotenuse is always going to be the diameter of the circle. So this beautiful right triangle right here, this is our diameter, but this is also our hypotenuse of our triangle, and then we have our two legs that are the same length. So if we want to find the area inside the circle but outside the triangle, that's this area right here. And I mean, there's no formula to find the area inside the circle but outside the triangle. But if you think about it, we want to find the area of the circle counting everything except for what is in this area of the triangle right here. So we can represent this area as the area of the circle minus the area of the triangle. Now, what is the area of the circle? Well, the area of the circle is pi r squared. That's the formula for area of the circle. And we know our radius is 8, so we can say this is pi times 8 squared. Right there. Now, what's the area of this triangle? Well, if we have this isosceles right triangle, and we know that the radius is 8, well, that means its diameter, or its hypotenuse, because they're the same thing, is going to be 16. So if this is 16, but this is an isosceles right triangle, or a 45, 45, 90 degree triangle, because we know if these two sides are congruent, these angles will also be congruent, leaving us with two 45 degree angles right here, and then of course a 90 degree angle across from the hypotenuse. So our rule with 45, 45, 90 degree triangles is our two legs, if we call them x, then the hypotenuse will be whatever that x is, square root 2. So if we say 16 is the equivalent of x square root 2, and we want to find the leg, or x, all we have to do is divide 16 by square root 2, which is equal to 8 square root 2. We can think about like rationalizing this by multiplying it by square root 2 over square root 2, which is just 1, so we're allowed to do that. And we end up with 16 square root 2 over 2, or just 8 square root 2. So that's our leg, it's 8 square root 2, which is nice because we need this leg, 8 square root 2, to solve for the area of the triangle. The area of a triangle is 1/2 base times height, and we know the base and the height because they're actually the same thing. Our base is right here, 8 square root 2. Our altitude or height is whatever is perpendicular to that, the highest point. So this is perpendicular right here, and our height is also 8 square root 2. So this ends up being 1/2 times 8 square root 2 for the base times 8 square root 2 for the height, or we can just write that as 8 square root 2 squared. So this ends up being 64 pi minus 1/2 times 8 square root 2 squared. Okay, so what is that? Well, 8 squared is 64, square root 2 is squared is 2, so we end up with 1/2 times 64 times 2. The 1/2 and the 2 will just become 1, so we just end up with 64 pi minus 64, and that's the area inside the circle but outside the triangle in inches squared.